Okay, let's talk about map. Map is a higher order function. So let's say you have a list L, and that list contains 1, 2. You know what? I'm going to just say it's a list made from range 1, 6. This is a bit zoomed. Yeah, it's not too crazy. With a closing bracket. Yes. So L is 1, 2, 3, 4, 5, and I want str is a function that turns whatever you put to it into a string by wrapping it to lovely string delimiters. And with map, I can map the function onto the list and apply or build a list from elements made from applying the function to each element of the list. Didn't work because that's not, sorry, we're not mapping fn. This is what we're going to do later. We're mapping string. That's the function I wanted to map. Map string onto L. I get a map object because very much like range, we're going to evaluate that just in time so that we're not wasting computing resources, cycles. So we're on the list of the map of the str and L of the map of string onto the list L, and that's your map. But higher order function, which are higher order functions, are functions that act upon. I like that, but take as args other functions. Not, I was about to write other lesser functions, sort of lower order functions, but higher order functions can act on higher order functions. So that's the first thing, and remember that functions are first class object. We have HOFs because functions are first class. In Python, meaning that this is a valid syntax. I can feed str, the function string, into another function. I can manipulate this object. I can even say, all right, let's call actually string gauge equal str. Without brackets, what I've done here is I have now an alias to my string functions, a string gauge of 4, 5, or whatever I've hammered is the string, right? And once you've done that, you can indeed rename string to print. And then you can do things like this, which is extremely bad practice, right? So I'm going to reboot my shell. Thank you very much. Right, that will work. So those are the 2 points I want to make. Higher order function. What I'm going to do is I'm going to define the best way to understand a higher order function. They're also higher order functions because you can write them in Python. It's very meta. It's not operating like print or indeed str as something that you couldn't rewrite yourself. I can completely define my map of fn, ln, lt as now. If the list has one element, if the length of the length of lt is equal to 1, then return the list. Well, a singleton. That's a list of an element. A list of one element. Fn applied to the first / sol element of lt. Fair enough. Why am I to be here, right? So in that case, we are going to return fn. Let's use return as a statement. I mean, we know this isn't Haskell. Let's not crazy with the function. Function applied. Notice it's suddenly changed color, right? So it's function now. It's not just an argument, but it's both because we have HOFs, because first class objects. This is the important part. Function applied to now the first element of the list is of course at index 0 because computing logic. Now this will run if I import main. Sorry. This will run because now if I import main, I can do my map. But it will only, I mean, that's not going to do anything if I pass in anything else. But my map against onto a list of one element. 1 bracket, 2 bracket, just 1 bracket is 1. Right, that's fine. So I've handled my edge case correctly. And then this is where we recurse, else we are simply going to return. Now this is where you need to hang on to your seat. This structure, you've got the boundary condition, the stop case essentially, which is with one element, and then you use the head and the rest, the car and the CUDA, if you're coming from Lisp, to return function of LT0. Sorry, let's make that into a list of the function of LT0. In fact, we also want to return list of function of LT0 here, because it has to be a list. And then onto that list we append, you can use plus, which works then for concatenation and does very much the same thing. We're going to append. Actually, instead of going LT index 0, I'm going to LT pop 0. So the beauty of that is this is going to return the element at index 0, but also remove it from the list. So now split what is now in LT is what's the rest of the list when I came in that particular call. And then plus what? Plus, watch for it, watch this. I'm calling myself recursively, and the function calls itself. It's an Ouroboros figure, if you'd like to do a perhaps a Jungian reading of this. And indeed, it's just the function on the list. Because now the list is the rest of the list. Otherwise, return apply to the first element, prepended, right at the beginning, appended to a recursive call to my map with fn, which I got wrong here, fn and the rest of the list. So that is what we've done here by calling pop, right? I'm not. And this, I mean, which would be so elegant if you didn't have all the comments, quite frankly. I'll suddenly look piffier. Again, import the main. My map, watch this, star onto 1, 2, 3, 4, 5. Close bracket, you got me there. Is 1, 2, 3, 4, 5, but it's strings. And how about, just to prove, like it's not a magic trick, because I could have said my map equals map, as I've done earlier. Let's not do that. This was very bad practice. What if I, just to prove you, like it's not, I'm not having you on, and this is actually this code here that is running and doing what the map function does. So those library functions, the higher order ones, they probably written in Python and the hood, quite frankly, or whatever. Reapply to what I'm saying is also true of Haskell. So string onto 1, 2, 3, 4, 5. This is very bad functional programming because I've just induced a side effect into something that was that's unfortunate. Oh yeah, sorry, I forgot, of course, because it's a type, it's not substitutable, and I'm missing a comma. Simple as that. I wrote this, right? Like, that's it. Zoom it out. Yeah, a bit nicer. 100. Let's look at 100. Yeah, that's still too long. So it's helpful to try and trim your comment lines so that the indent still looks nice rather than have this, because by default the line wrap will indent it to just one more tab, one more whatever length you have. Also nicer to have a little space after your hash in the comments. Line colon 54, I could go a bit farther. Colon 66, colon 78, I can live with that. I would wrap at 80, and in fact at 100% you'll notice it wraps at 80. This will because of, to be honest, that move, so that doesn't mean anything. That was it. Well, 10 minutes. Thank you for watching. I'll see you next time.